Okay, welcome to this video. In this video, we're going to talk about what I know about science and why I like science. So, science is scientific. What does that mean? It means it revolves around explaining the world around us as well as calculations. So that's the two areas of science: explaining the world, calculations. And the branches of science, when you get more advanced, are geography, how the earth actually works, space, astronomy, chemistry, how chemicals react, biology, how the human body works and how other animals work, climate, how environmentalism works, mechanical and civil engineering, so these are structures and forces, how forces work, and then electrical and nuclear engineering, which are how electricity and magnetism forces work and how nuclear forces work. There's four fundamental forces: gravity, electromagnetic, nuclear, and some other kind. Radiation, maybe? I don't know. Now, and you want to try to get some sort of understanding of breadth and vertical progression through technical expertise, which means you want to have some biology, some chemistry, some physics, some kinematics, some statistics, as well as some mathematics. And then you can specialize into which area you like and get a more deeper understanding. And how does science help you in real life? Well, the calculation part helps immensely. When you can think of things in terms of actual ratios and numbers. For example, you might be cooking something and then you have to know what the difference between 200 grams and 1 kilogram is, or the difference between 50 grams and 250 grams. Or if you're driving somewhere, the difference between 20 kilometers and 80 kilometers. Or when your speed, the difference between 15 miles an hour, and 40 miles an hour. That's different. You got to have a sense of, or money, the difference between $30,000 and $300,000. So to have a sense of quantity, and then also to know ratios like percentages, like 80% of that, 99% of that, 10% chance of error, things like that. And then you can write them down. So you can express things in terms of formulas. You can also write sentences and use terms like scientific terms and names of elements, or terms like velocity, speed, weight, force, mass, temperature. Temperature is a scientific measure because it goes on a scale. So you have a scale. It can be in Celsius, Fahrenheit, or Kelvins. One sec. Okay, so yeah, you have terms, you can write down sentences, you can write down facts. Then you have procedures like experiments, which can lead to benefiting science and society in general. Like you can have research, you can have a procedure that says in a control study group, if we do this, what will be the outcome over the long term? So if we have like 100 people that need have this problem, if we add this to the environment, what's going to happen to those 100 people in the future, and how can we make changes that betters them? This works in medicine, this works in digestive health, exercise, the human body, as well as engineering like vehicles and technology. You say, how can we make things more productive, more efficient, more faster, less waste? So these are done by making small changes and researching and using data and the easy stuff like just data. So you said we did this, we tracked points, we measured points, and this is what we got from the data. And these are the conclusions we reached. Then you write conclusions. You write the purpose of the test, the procedure you used, the errors you encountered, and then the conclusions you reached. You're going to repeat that all your life throughout science. Your purpose, the procedure, the results, the sources of error, and the conclusions, and the recommendations, and then a budget and a schedule for how you're going to do a said project you're going to work on. And then you have you just got to be good with numbers, good with terms, good with theory. So there's also theory. So theory involves like how well you know the equations and the principles. These two things interact like this. The fundamental underlying mechanism for how this functions is this. Stuff like that. And then the calculating part. So you got to know, like, if you have an unknown quantity, how you're going to figure it out based on the known quantities. Or if you're going to perform an experiment, what's going to be the expected results. If you have a car that has 100 liters of fuel, how far and how fast is that fuel going to take you to somewhere? If you got a fire with this much oxygen and this much fuel, how big is that fire going to get? So you can calculate and see what's going to happen before it actually happens. So you can use it as prediction. So science can be measuring results and improving things, or it can be predicting things and designing things. So you design things, you predict them first on pencil and paper, then you can use a computer program to analyze what event is going to occur. And so you design, you predict, and then you come to a conclusion and you measure and you reach results. And you start learning science in school, like elementary school and kindergarten and middle school and high school, and then you can do science in university. So all stages of life have science. And you can find science on the internet, like documentaries and lessons and just those little mini series of science and stuff like that. National Geographic. But science plays a role in the real world because then you'll know how things interact. Anything could be science. Knowing how a tire changes direction based on how the steering wheel works. Hydraulics, right? You can't just use your hands to turn the wheel and expect the tires to move. You're not physically turning tires with a ton of mass on top of the tires with your two wrists. It's hydraulics. You got some sort of liquid that's compressing and making the force. So a small force applied changes to a big force applied. It's hydraulics. Stuff like that. Buoyancy, how boats work, how it floats, how it turns. Stuff like that. How engines work. How temperature works, how the sun and the cycles of rain works. How natural disasters occur, how hurricanes occur, how flooding and landslides occur, how earthquakes occur. Earthquakes are not the collision of tectonic plates, but the release of tectonic plates. Like, they come together and they're stuck, and then when they get released, that's when the earthquake happens. So they get stuck and then they release and the earthquake happens. So it's like that. Hurricane is a change of pressure and temperature. So hurricane is when you have high cold air and hot air coming together. There's pressure and temperature changes, and they start spinning into a vortex. And they move along and they pick up water, and they get more powerful as more pressure changes happen, and they travel towards the inland. And how far is that hurricane going to last? And when is hurricane season? And why there's no hurricanes on the west coast where LA is, but there's on the east coast, is because there's more warm water that travels up from Mexico, the Gulf of Mexico, and that collides with the cold air from the Atlantic. Whereas in the Pacific, there's no streams of warm water which bring warm air on top of it. It's all like cold water or something like that, So, neat facts. How the sun and the planets rotate. What else? What other interesting facts are there? Aerodynamics. How a soccer ball is kicked. How it spins and curves throughout the air. Buildings, how they're designed to withstand earthquakes. They go deep into the ground. So, and they're not made to be rigid. If they're made to be rigid, then a little bit of conflict results in collapsing. They're made to be flexible, so they can flex like that. Like goalies for hockey goalies. The mask is designed to pop off. So if they get hit in the face, the mask buckles and releases, absorbing the pressure. If it's a hard structure like this and it hits something, it can crack. It has no absorption. So by allowing it to absorb and be softer, then it can withstand more force and protect the safety of what's inside. So if you have a human skull inside, it needs to be protected by something that can withstand the collision and not damage the inside of the material. Whereas if you just put something very rock hard and no absorption, it's gonna ripple. And then you can measure it. You can test it out. You can put sensors and submit it to contact and measure the readings on the sensors of the force of impact. And that's how you would measure that with science. So science is unique all around us. Then you have medicine. Like you're gonna. It's not just about healing the person. It's about how you heal the person. So like they're allergic to this, or they have this condition, and they need this medicine. But this medicine interacts with this medicine, which interacts with this medicine, which interacts with this condition. So this is the best way to go about it. This is the safest way to go about it. This is the cheapest way to go about it. This is the less complicated way to go about it. This interacts with this, which interacts with this. So we got to change this and this and this and lower the dose and increase the dose and side effects and symptoms. And all that balances out to a medical. And then you have a team that works with you. So this person does this person measures this person consults this. And through a team effort, you have the science of medicine. and then uh, and then you had like the numbers and stuff like that. So like I said, we already covered that. Well, that about does it for science. It's nobody knows all of science. It's a huge endeavor, but start thinking about numbers, start thinking about principles, start Googling. You do a lot of Googling. Google is your best friend when it comes to science because you always have some sort of question, and then you can read articles and studies on the news and read about, like when you Google what's this, often you'll get links to even articles that summarize procedure, results, conclusions, and stuff like that, so you can see all of that for yourself and learn more about science, and then get better at numbers like percentages, fractions, ratios, and scaling, and learning what the proper scale is, whether it's in the tens, the hundreds, the thousands, the millions, the billions, the trillions. Learn about how you differentiate between scales and metric units versus standard units, Fahrenheit, kilometers, miles, Celsius, degrees, grams, pounds, kilograms, feet, inches, centimeters, meters, kilometers. And until next time, peace.